All right, so today we're talking about slope of a line. So there's several different ways that you can find the slope. So one way we talked about is y, if we get y by itself, if we can solve for y by itself, we can find the slope. Now, before I call that red and that green, and what we said was that the b, or the number that stands alone, would be your y-intercept, which would be 0 comma b, okay? And this m is your slope, which I said was rise over run. And also I said that if we rise upward, it'd be positive, and downward would be negative. And with the run, if we go right is positive, and we go left is negative, right? So that's one way of doing it. Another way is with a graph. So if I'm given a graph, I could find a slope as well, okay? And third is if I'm given 2 points. And we'll call those 2 points as x1, y1, and x2, y2. So if that's the case, then my slope is going to equal to y2 minus y1 over x2 minus x1, okay? And then the fourth is going to be talking about horizontal lines and vertical lines. Well, let's go through all of them, okay? So if I'm talking about choice 1 here, which is y goes down x2p, so let's say I'm given negative 8x plus y equals 5, all right? And it wants me to find the slope, then I know that I have to get y by itself, okay? So, therefore, I get y is equal to 8x plus 5. So, in this case, I know that my y-intercept is 0, 5, and my slope is 8, or you could call it 8 over 1 if I was actually graphing it, okay? So this would be the main answer, but 8 over 1 if I'm graphing, okay? All right, so that's that's the method 1, or possibility number 1, all right? So possibility number 2. So let's say I have a graph, let's call it, let's use this one, why not? Okay, so I gotta move this. I need to move this over more. There we go. And then I gotta shrink this. Okay, so let me see here. All right, so one of the things you could do is say, okay, I'm gonna pick 2 points. Easy 2 points. There's one right there, and there's one right here. Okay, so I'm gonna use what I've learned previously. All right, I'm going to use the rise over run. Okay, so rise over run. Okay, so how do I get from point A to point B? Let's do this. Let's call this point A to point B. Well, in order for me to go from point A to point B, now again, rise over run is only either up and down or left and right. So that's my only movement. Okay, and the rise, the up and down, will go on top, and the run, left and right, will go on the bottom. So how did I go from point A to point B? I went down 1, 2, 3, 4. So I went down 4, and I went left 1, 2. So I went left 2. So therefore my slope is equal to positive 2. And there's my slope. There we go. Okay. Now, so that would be on the graph. So again, I know that this is right because it's steeper than 1. Okay, so 1 would be up 1, right 1, up 1, right 1. So if I had a slope that was 1, it would look something like this. Okay, that would be up 1, right 1, up 1, up 1, right 1, up 1, right 1, up 1, right 1. So this would be a slope of 1. And I know that this is going to be steeper than that, so 2 would make sense. The more shallow it is, okay, so in other words, if I took this right here and I said it's steeper, then the slope is going to be getting larger and larger. But the more shallow it is, okay, then that slope is going to be less than 1. So this is 1, these would be less than 1, and these would be greater than 1, okay? So that's why I knew, okay, you know what? This can definitely be a possibility. The other thing is that what I know is this. If the graph, if I scan it from left to right and the line is going upward, then I know it's a positive slope. And if it was going downward, then I know it's going to be a negative slope, okay? And this is a positive slope, and therefore I do believe that my answer is true, okay? So that's very important. So make sure that you kind of gauge that, all right? Okay, so method number 3 was given 2 points. So method number 3 was given 2 points. So let's look at that. So let's say we're given -2, -9, and 6, -5. Okay? Now, I know over here it's a little confusing why they call one x1, y1, what the other point x2, y2, and what does this really mean? So all that really means is keep track of what you're using, okay? So if you're using the y of the second point to start on the top, then you should use the x of the second point on the bottom, okay? So that's where people kind of make their mistakes. They kind of want to play fair. So if I want to find my slope here, then if I do y2 minus y1 over x2 minus x1, and I decide that that the orange point goes, I'm going to use the orange point first, then I have -5 here and 6 here. And then minus -9 here and -2 here. Okay? Or, you know what I should do? I should call this, make that green. So that means I need to make this green, this green, and this orange. Here we go. That looks better. Okay. Or I can say, oops, I'm going to put -9 here and -2 here, minus, and put -5 here and 6 here, okay? So notice that this is the orange point going first, and then the green point going second, and then this one has the green point going first, and then the orange point going second, okay? And notice that is the y values are on the top and the x values on the bottom. So no matter how we do it, if I did the orange point first here, this is -5 plus a 9, so that's a 4, over 6 plus a 2, which is 8. So this slope is equal to 1/2. Well, let's take a look at over here. There's the green point one first. -9 plus 5 is -4. Over -2 minus 6 is -8. So this is also going to come out to be 1/2. So again, depending on what you want to do, I'm still going to get the slope of 1/2. Okay? So that will still work. And then 4, we're going to talk about horizontal and vertical lines. Right? So 4, you know what? Let's not even write it. Let's just actually draw it. So here's a horizontal line. And then let's draw the vertical line. Okay, so the way I look at the slope of these is you can certainly pick you're certainly welcome to go, okay, I want to pick 2 points if this was on a graph paper, right? And then do, the change in x over the change in, the change in y over the change in x. You're welcome to do that. But here is the way I look at it. I use the example of skiing. If I was to ski on this slope, which is basically on flat ground, how much fun am I going to have? And the answer is 0 fun, right? So the slope of a horizontal line would be 0. Okay? Now think about this. Even if this is not on a graph, okay? And I know that the slope is equal to rise over run, right? So if you look at this, going from point A to point B, how much did I rise? I didn't rise any. How much did I run? Something. Well, what's 0 divided by anything? Still 0, okay? So you can think of it this way, or you can think of it the other way. That's certainly fine. Either way, it's still going to give you 0. All right, let's look at the vertical line. And let's go 2 points here, okay? So if I look at the rise, I should probably actually do this. This is not quite vertical, so can't erase it. So I gotta do this way, and do this way. There we go. Okay, so I got 2 points here, right? So let's call it A and B. So if the slope is still rise over run, okay? Actually, let's do it this way. Let's take this, put this over on this side. Okay, so it's rise over run. So let's take a look. From A to B, how much did I rise? I rise something. I don't know what because I'm not on graph paper, right? Some. Over, how much did I run? None. And what happens if you put this in your calculator? The slope will be undefined, okay? So, and the way I look at this as skiing, here's my skiing. Now, if I was skiing here, 0 fun, no fun at all. It's just me staying there. I might as well just do wall squats. But if I was to ski on this slope, what would happen? Ah! Splat. So my body would be undefined. So that's the way I look at it. And that's the example that I usually use in class as well. But you're certainly welcome to use the rise over run if you want to, because that will also give you the same thing. All right, so the next thing we're going to talk about is parallel versus perpendicular. Okay, so if 2 lines were parallel, They'll look something like this. Right? So what do I know? I know that the slope of the orange line is going to be the same as the slope of the green line, okay? So that means the two slopes are going to be exactly the same. Now, this is going to be the same slope but different y-intercept because they're parallel, right? So the slope is going to be the same, but they're going to intersect the y-intercept at different points. How about perpendicular? All right, so if I had a perpendicular line, I want to make it more extreme here. So with perpendicular lines, what you know is that it intersects each other at a perpendicular, meaning it intersects each other at a right angle, okay? So if you noticed, going from left to right on the orange line is going to be something shallow, right? Like a 1/4, 1/5, something smaller than 1, but shallow, but yet positive, okay? So if you look at this, this is positive and shallow. Okay? Now, if you look at the green, is it positive or negative? So go from left to right, it's going downward. So this is going to be a negative slope, and it's going to be steep. Okay? So if you think about that, that's going to kind of tell you a story of how the slope is going to be. The slope here, let me put it this way. The slope of the orange line is going to be the same as the slope of the green line, but negated and flipped. Okay, what do I mean by that? So let's take a look at that. Let me see here. Let me move this piece right there up to here so that, or up to here, just so you can see it. Okay, so what do I mean by that? All right, so let's do some examples here. Let's draw a table. Okay, and I figure we're gonna do some examples here. Okay, so let's say I'm gonna be giving you slopes, and you gotta tell me what the parallel slope would be and what the perpendicular slope would be. Okay, so if I said to you, this given slope is 3/2, the parallel slope would also be 3/2 because they're the same. Perpendicular, okay, the way I want you to think about perpendicular is flip and negate. So it's gonna be negative and then it's gonna be flipped. Okay. How about negative 1/4? Parallel slope would be negative 1/4. If I was to flip and negate negative 1/4, what would it be? It'd be 4. So negate it makes it from negative to positive. I flip the 1/4, it'll be 4/1, and 4/1 is just plain old 4. All right. Let's see here. Negative 2/3. Parallel would be negative 2/3. Flip and negate, I get 3/2. Let's say 2. Parallel slope will be 2. What will be the perpendicular slope? Okay, so you got to make the 2 as a fraction, which is 2 over 1. Negate it, since it's positive, it's going to become negative. And if you flip 2 over 1, it'll be 1 over 2. So it's negative 1/2. Okay, so perpendicular, flip, and negate. Okay, negate means to flip the sign. All right, so hopefully that helps. So let's do an example of where they're gonna ask you to do this. So let me see here, insert, file. There we go. All right, so it's going to want to know, decide whether the lines are parallel, perpendicular, or neither. Okay, so I got 2 lines here. Okay, they each have an X and a Y in it, so that means I have 2 diagonal lines. Okay, so let me take this first one as red and the second one as green. So I'm going to take the red, which is negative 2x plus 7y equals 2. In order for me to know the slope, I solve for y, or get y by itself. So I got 7y equals 2x plus 2. Divide each one by 7. So y is equal to 2 over 7x plus 2 over 7. Now, you might say to me, hey, how the heck am I going to graph 2 7s? Well, this is not about graphing. This is about just determining whether these lines are parallel, perpendicular, or neither. That's all I care about. I don't care about anything else. The y-intercept doesn't help me with parallel or perpendicular. So with the green says 7x plus 2y equals 10. Okay. So again, I gotta get y by itself. So 2y is equal to negative 7x plus 10. Divide everything by 2. Y is equal to negative 7/2 x plus 5. Okay? So all I care about right now is just the slope. I only care about this and this. Okay? So the slope here is 2 over 7, and the slope here is negative 7 over 2. So if I look at just those 2 slopes, can I flip and negate one to get the other? It doesn't matter which one you flip and negate, they should work for each other. And the answer is yes, you can. So therefore, I know that these 2 are perpendicular to each other. All right. Well, I hope this helps. Let me